Oh, that's way quieter. This is part 4 of a multi-part build series. In the first video I went over all the electronic components and why I chose the ones I did. In the second video I assembled most of the electronics into a computer case and customized it by adding CNC connectors to the rear and mounting all the controls to the front. In the third video I finished building the main body of the CNC. This video is about finishing the wiring and anything else I need to get it functioning. Now, one of the things I wanted to do in this video is I wanted to put the cable chain on here. I got a couple of these. One I was planning on laying across here. The other one I actually was thinking more about putting it on the outside, and that's going to give me a little bit more range of motion for the spindle to be able to carve things out. So my idea was to take 2 of these maybe and kind of come up with a little 3D printed bracket that goes on front and back here and create a little bit of a track here, and then we could have the cable chain kind of laying here as it goes back and forth. And I think that's actually going to work as long as it's lined up. Okay, I've gone ahead and whipped up something in Fusion 360. It's printing off now. The next thing I want to do is get all the stepper motors wired up. Okay, the part's finished printing, and I went ahead and I took off the supports. Okay, that looks like it fits well. Okay, so I'm happy with how this is all fitting, and I'm going to go with that for the final design. And then I just need to go ahead and design something up here that this can attach to for the cable chain that's going to go here. Actually, it'll go right here. And this will attach right to the 2040 extrusion. And then I need to design something that will attach to the back of here that this will attach to, so that when it moves back and forth, it will go ahead and keep up with this. Okay, I've gone and cut these down to length, so let's go ahead and put these in for now. I actually had this mounted wrong. It was actually supposed to be mounted like this. And I have both of these adjusted so they're pretty close to where I think they need to be. And actually I've learned that having the bigger spindle does not actually remove any of the room that this can move. Okay, I've gone ahead and moved this over as far as it'll go. It looks like there actually would have been enough room for the cable chain if you don't want to go ahead and build a track, but since I built it, I'm just going to go ahead and leave it there. So I'm going to go ahead and leave this limit switch as it is and just design something that attaches into these 2 nuts up here, and I'm thinking maybe hooking onto these longer screws on this stepper motor, and then I'll have it sit on here. I'm thinking something that sits up here and then has a hole for the stuff to go through, and then it can kind of go around the sensor or whatnot. Okay, I've spent about the last week going ahead and designing all the parts, so now I can get all the cable chains in place, and I'm going to go over those parts with you really quick. I was trying to figure out something to attach to here, and I came up with this nice design that has a little clamp, kind of print in place, so there's a little bit of a gap there, but it ended up being that these were a little too low for this, so I ended up redesigning it so it is a cap that fits here, and then it has a piece that fits here, and the cable chain will attach to here, and I'm actually going to reorient this so it goes this direction. So the cable chain will go up and over here, and then we have this piece here which will mount to the back of here, and it has room for one cable chain here, and the other cable chain will mount on the bottom, and then we could have parts come up through here. This piece here is actually, it goes over here and it'll hold this cable chain and just attach in with these little nuts down here. And in order to not have to worry about the parts going around or over this, I created a little cable pass through here, and this sensor holder will just attach to this, and then this will attach to the bar where these would have gone. I realized when I was measuring stuff that the spindle was actually hitting the top plate here, and so I kind of went ahead and redid a design on there with a little cutout here, and I think I am ready to go and assemble everything. There it is. So I've gone ahead and inserted some tubing here, and you can see it makes a nice arc, but if this were flat, I think it would look a lot better. So what I've gone ahead and done is I've designed and printed a piece that will attach here. And as you can see, it has a really nice arc that goes over here, which is exactly what I was hoping for. Now these cable chains are on here a little bit long, and so what I need to do next is get these stepper motors hooked up, because I really don't want to crank them by hand. And then once I get them in their far positions, then I can go ahead and remove a bunch of the links in the middle here and get them to the right length. Okay, I've gone ahead and wired the Y motors up here, and I loaded just a vanilla version of Gurgle, no configuration or anything, and that's running on the board here, and I have CNC JS. Now that's supposedly 10 millimeters, so I think there's a setting on those stepper motor drivers that is wrong. Right now I'm just trying to move this to the end there so I can get this cable chain shortened to the proper length. Okay, that's probably close enough. I knew these stepper motor drivers may be loud because they were the cheapest variety. In anticipation of that, I actually got these DM542s, which are a little bit higher quality. As it is, these are a little bit thicker. So I will go ahead and install these, which is why I'm not too concerned with the fact that the steps are off, because I can adjust it on these. So one thing I figured out with these dip switches is I thought up was on, but I didn't notice this little on down here. So I actually had these dip switches in the opposite position they were supposed to be in, which is why I was getting my steps off so much. Okay, I've gone ahead and wired everything up here. Basically, a lot of these connectors were backwards from the other stepper motor drivers. and so it was a matter of just getting the wiring to go in a different direction. It's a little bit more crowded in here like I expected it would be. I think I have everything reconnected how it was. So I'm gonna go ahead and test that out next. Oh, that's way quieter. Whoa, that's so much better. I know my steps aren't set correct, but I'm happy with that. Okay, that was totally worth it. So one peculiar thing I noticed on here after I swapped around the stepper motor drivers is one of the stepper motors was going one direction and one was going the other, despite them being wired exactly the same and having all the same settings. So I went ahead and I swapped around the A and B pair of wires, and that seems to have solved the issue for now. I'll let you know if I figure out anything else weird. With the stepper motor going the wrong direction, it actually had gotten the frame so it wasn't square anymore. So I used this to, went in here, kept driving only one of the stepper motors ahead till it was all square, so should be good now. I'll reinforce it a little bit later, but I didn't want it to be out of square for too long. Okay, I was trying to figure out what I need to do to get these inductive sensors working, and they're a little trickier than I thought. You're supposed to actually supply 12 volts to them, and then when they're triggered, they will supply 12 volts back. The thing is, I have an Arduino based board, and it has 5 volt logic, so I need to convert that from the 12 volts to the 5 volts. One way you can get around that is with an octocoupler. And I happen to already have some octocouplers here. These ones will convert the 12 volts down to the 5 volts here. When I connect the signal and the ground, you can see I have 5 volts. And if I touch this, it goes close to 0. It's like half a volt. So you can see it is going, it's just the inverse of what I wanted, but that's not really an issue because I can actually invert the limit switch input in the firmware. So these are good to go. Okay, I made a few mistakes here and I can fix them. First of all, this cable chain is just too small for 2 of these tubes and the wire that goes to here. This is 10 by 20 millimeter, and I just ordered some 10 by 30, which means I'm gonna have to redesign this. I should have made it more centered instead of offset to one side. That was a mistake. The other is this needs to be taller because I did not take into account how tall this plug was. So it was right up against the cable chain opening. Okay, I've gone ahead and redesigned this part here. I made it a little taller. It's wider for the new wider cable chain, and I redesigned this as well. I added a little bit of a 45-degree angle in here so that the tubes can kind of ease their transition there. So a new problem has developed here, and I'll go ahead and show you, but I'm not sure what's causing it. So if I move it, it makes this horrible squeal. So I've tried adding some grease to it and oil and cleaning this, and I haven't quite figured it out. So I've gone ahead and taken off the ball screws off of this, and it actually slides really nicely. I was a little worried it was the linear rails, but they seem fine. And the ball screws turn fine, so I'm not worried about that anymore. Okay, just on a whim, I decided to hook up a stepper motor to the CNC, and here's what it sounds like. So apparently the stepper motor was making that squealing sound, and the frame of the CNC was acting as a big transducer, so I thought it was actually coming from the CNC, and it wasn't. I think this is related to the issue where one of the motors was going backwards and one was going forwards, so I'm going to go ahead and troubleshoot that next. I ended up rewiring the wiring back to the original wiring I had. I happen to have an extra stepper motor driver, and I've hooked it up here, and as you can see, they're now both turning in the same direction, so I suspect I had a defective one. Okay, I've gone ahead and reassembled this for the most part, and now you can see the squealing problem is gone, so that got fixed. Okay, I have everything in the chains now, and it's actually looking pretty good. You may have noticed I went ahead and redesigned this without the top on here, and I realized with the cable chain I could actually flip the connector around, which made the design a lot simpler. What I'm going to do next is get all these cords hooked up to the computer. I have these limit switches which can move because I haven't gotten them in their final places. So I went ahead and got the limit switch mounted here. I added a couple links into the cable chain and removed the little wire holder here because I figured it would make it a lot harder to take this apart. And I think this looks a lot better and a lot neater. One thing I was a little unsure of when I was going to wire this was running a cable from here to here, because I didn't have a really good way of getting it in here. I found these clips online, and these are okay because they just kind of snap in on here and they hold it, but I didn't feel like they were going to hold it very well. So I went ahead and I redesigned these so it's an L shape. And so now it just kind of clips on one end and then snaps here, and it holds the cable nice and tight here. So the next order of business is to get the steps per millimeter on each of the axes all dialed in, so that when I tell it to move a millimeter or a centimeter, it will move that distance. What I found is as I was tuning it, it was getting really inconsistent results between when I was telling it to go 10 millimeters or 1 millimeter. I looked a little closer at this, and I noticed it was actually, it has 5 to 24 volts on each of the plus ones, and the signal is actually supposed to be hooked up to the minus ones. So I went ahead and rewired it and with a common 5 volt to each of these, and then I just hooked the signal wire up to each of the other ones, and I'm actually getting much better results. I started with going and calculating what the steps per millimeter should be in an ideal world, and then using my calipers, I taped it down in place and I'd move it, and then I'd just adjust the steps per millimeter and it would be good. For the Z-axis I used an SFU 1204, which means it moves 4 millimeters for each revolution. So I just had to do a little bit different number for the starting value. And so the next step is to get the spindle going here. That's loud and scary. So you can see that even when this is set at 72, that is running here. Now I'm going to go ahead and program it so that it is using the inputs from the IndyMill. So it looks like forward and reverse aren't doing anything. This is flashing, so that may be part of the problem. So I'm going to go ahead and play around with that off camera a little bit. Okay, I sort of got this working. So if I tell it to go 300, then it's going about 120 here. So it's not quite getting the right frequency. I'm gonna go ahead and hook up this board here. What this will allow me to do is send a pulse width modulation signal from the Arduino to there, and then this will go and go between 0 and 10 volts, and I just need to supply it with 12 volts here, and we should be good to go. Okay, just wanted to give you an update on where I was at here. I was running an older version of GRBL, so I wasn't getting the settings I needed in order to go to the right range, and this board here was actually the wrong one. This is meant to convert a voltage into PWM as opposed to PWM into voltage, so that's useless. And then, so I got another one here that's the right one, but When I power it by 12 volts, the maximum it's able to output is 9 volts, and I think it's just a very inefficient one. Okay, so it looks like this board was actually maybe defective, because when I hooked up 24 volts to it, it completely stopped working. Even hooking back up to the 12 volts, it's still not working, so have a replacement coming. This is just getting really frustrating at this point. Okay, so it's actually been a few months since I was working on this, and I was running into a lot of trouble and I got stuck. So I actually have it running now, and I'm going to go ahead and show you. I have the VFD on, so I can go ahead and hit forward, and it should start in forward, and then I can stop it, and then I can hit reverse, and it'll actually go into reverse. The only caveat on this is if I go from forward to reverse, then I start getting an error on the VFD, and I will go ahead and show you what I did. So what I have here is I have the 0 to 10 volt board, which is controlled by the PWM, and then the output of that goes into the VFD itself, and it's actually driven by this 24 volt power supply. Now I have this little relay here. This is from Adafruit, and I basically have this hooked up to the spindle direction, which will control it. Right now it's in reverse when that's on, and what this does is it goes between the X ground here and the forward and reverse labeled inputs here. The reverse is this blue wire here, and it connects to the normally open here, and that seems to be working really well. And the real secret was the panel settings, and I'll go ahead and put that down in the description. So next I need to go ahead and clean this all up and get it all looking tidy. Haha! Don't think that's going to be self-healing. There, that looks much better. So next I need to go ahead and install this reverse Aviator plug, and this is different than the other Aviator plugs because the jack is on this side and the plug is on this side. And the reason I want to install this is because it's for the spindle, and I have 220 volts running through, and if I have it with the pins, if you accidentally touch it, you could get zapped. And by having a jack on this side, it's going to prevent that from happening. Okay, let's go ahead and check if that works. Cool. Okay, so I've been doing some research as to why the VFD is going into an error state when I go from forward to reverse or reverse to forward without stopping in between. And the reason it is because I don't have a braking resistor installed. I thought it was an optional component, but it's actually considered a highly recommended component because it will prevent damage to the VFD. I've gone ahead and ordered one, but it won't be here for like 3 to 4 weeks, so I will install that later, not in this video. And if you have a similar VFD, I would recommend getting one. Now on the VFD, I have it displaying the frequency. Now for the motor that I have on the spindle, it actually goes between 0 and 400 Hertz, and it also goes between 0 and 24,000, which means that it goes about 6,000% of what it's showing on the frequency here. Now if I want to go ahead and show the RPMs, I'm going to go to Program, and then I'm going to go to 00.23. It shows 100, and according to the manual this is a percentage of the frequency, but it's actually more of a multiplier. So if I want to display the 24,000, I'd have to put in a multiplier of 60. Let's go ahead and change that to 60, and then I'm going to set it. And then for the 00.24, if we set it to 9, that is to display the user variable. And if I hit at 24,000, you can see it goes up, and then it displays 4,000. So if we want to display 2400, because that way we can see the more important numbers, we're going to go ahead and set this to 6 instead of 60. It'll now display the 2400 RPMs for 24,000. Now for this spindle, it's actually a water-cooled spindle, and you may have noticed this, and what this is, I actually have this little plug thing with a little remote button on it, and that allows me to remotely turn on the water pump. So if I go ahead and hit the button, you might be able to hear the pump, which I actually have inside this little bucket here with some water currently. I will change it over to some coolant that you use for an automobile once I do get it home, and that'll help prevent any kind of damage or rust to the motor. But for now, we're just going to go ahead and use the water. Next, we're going to go ahead and install the spoil board. I have this 3/4 inch MDF. It's cut down from a 4x8 sheet. There we go. Now I need to install a bunch of little angled brackets here in order to attach it. I shouldn't need to worry about the CNC spindle hitting it just because of the width, and I just do not have it going all the way up to the edge here. I hope you enjoyed this video. This video ended up being much longer than I thought it would be, and I'll be testing the CNC in my next video. I'd like to thank my Patreon supporters for helping make this video possible. If you'd like to support me on Patreon, the link is down in the description. If you're new here, please consider subscribing. If you have any thoughts or suggestions, please leave a comment, and I'll see you in my next video. Now I'm going to go ahead and install this reverse Aviator plug, and what this is it allows you to have brain farts. Let me walk out of the way of the camera. Sure, Melissa, stand right in front of the camera when you explain. I swear, editing is like 90% of editing out me searching for tools or parts or whatever.